So we have already discussed the influence line diagram for reaction RA and RB. So today we shall start with the influence line diagram of shear force. Okay, that those are we have already discussed influence line diagram for RA and RB. So now ILD for shear force. So suppose we have a particular beam, simply supported beam, and so this is the load W, and suppose this is the section. Okay. And one thing you can you know that for this case this is W and this is reaction RA and RB, and if this distance is x, so this distance would be suppose L minus x, because we have length of the beam is L, so this length is L. Now the reaction RA equals W into L minus x divided by L, and the reaction RB will be W x by L. All of you know that. Okay. Now the shear force diagram will be like this. For this case, this will be the shear force diagram. This is the negative part and this is the positive part. And this value, you can see this value is nothing but value of the reaction W into L minus x divided by L. Okay, and this value is nothing but equal to the value of RB. Okay, so two things we can notice here. One is the value of the shear force will be the equal to the value of the reaction here, and this is the positive shear force and this is the negative shear force. That two things we have to consider. Now if x equals to 0, here, then this value will be equals to W. Okay, so or if x equals to 0, then this part will be 1. Okay, so now if you place this W equals to 1, if you place W equals to 1, then this will be the diagram for the reaction for RA, and this will indicate the shear force, positive shear force. Okay, and for the negative shear force we have to consider the negative side of the line. This is the line, beam line. Okay, and above the beam line this is the positive part, and below this line is the negative part. Okay, so what we can do, this is actually the influence line diagram for shear force. So this is the positive part. I should okay, this is the positive part and this is the negative part, and this value will be 1 and this height will be 1. Okay, and now what will be the influence line diagram for shear force actually? So below this section you just draw a particular line and connect these things, this part and this part. So this is the influence line diagram. This green line indicates the influence line diagram for the shear force. So this will be the positive part and this will be the negative part. Now, so for for this particular section, we have to calculate the shear force value. So, what is the shear force value? You know the formula, that is, you draw a vertical line below the load, and we have a negative part at this part. Okay, so at the left side of the section, we have the negative part, and the right side of the section we have the positive part. So at the left side of the section we have this particular height, so we have to calculate this height and multiply by W. So you will get the amount of shear force due to this application of load W at this section. Okay, at this particular section. So this is ILD for shear force. So let us do a problem. Suppose we have a beam and we have a load, suppose a 20 kilonewton load, and this distance is suppose 2 meter, and this is suppose 4 meter. So total 6 meter length, point A, B, C, and this is the section. So this section suppose 3 meter from the left side. Now first of all calculate the reaction RE and RB. So for reaction RE, you just draw the influence line diagram. This is the influence line diagram for RE. And this value is 1. Now for to calculate the reaction, you don't need any section. Okay, you don't need any section. You just place the vertical line below the load. Okay, suppose this distance is y1 and this distance is actually, you know, the 4 meter, and this distance is 6 meter. So from the similar triangle, we can write 1 by 6 equals y1 by 4. 1 by 6 equals y1 by 4. Hence y1 equals 4 by 6. That means 2 by 3. Now reaction RA equals W into y1, that is 20 into 2 by 3. So the answer is 13.33 kilonewton. Okay, so now you calculate the reaction. You calculate the reaction RB. So what will be the reaction RB? First of all, draw this beam again. This is 20 meter, 2 meter and 4 meter. So this value is 1 and you have to calculate this y2. So this is 2, this is 6. So we can write 1 by 6 equals y2 by 2. So y2 equals 2 by 6, that is 1 by 3. Hence RB equals W into y2, that is 20 multiplied by 1/3. So the answer will be 6.67 kilonewton. Okay. So this value is 6.67 kilonewton and this value is 13.33 kilonewton. Okay. Now we have to calculate the shear force. We have to calculate the shear force at this particular section due to the application of load 20 kilonewton at a distance 20 meter from point A. Now so this is your beam, this is 20 kilonewton load, 2 meter, 4 meter, and this is the section and this distance is 3 meter. So first of all draw the shear force influence line diagram for shear force. This is the influence line diagram for shear force. Now what you have to do, you have to draw a vertical line at this position below the load. So this distance is y3. Now you have to calculate the y3 first of all, then you can multiply it with the load W. So we can get the amount of shear force at this particular section. So how can you calculate? This value is 1 and this value is 1. Okay. So you see this distance is 2 meter. This is 2 meter. So we can write 1 by 6 equals y3 by 2. So y3 equals 2 by 3 and 2 by 6, that is 1 by 3. So shear force will be W into y3, that is 20 multiplied by 1/3, that is 6.67 kilonewton. Okay. So this is the answer. Now let us try another example. Suppose this is a beam. We have 2-point load. One is 30 kilonewton, another is 20 kilonewton. So this is 1 meter, this is 2 meter, and this is 3 meter. So total 6 meter span. So first of all, calculate the reaction. So this is 1. This diagram is influence line diagram for RA. Now draw one vertical line below this 30 kN load, another vertical line below the 20 kN load. So this is Y1, this is Y2. Now you see this distance is 3 meter and total distance is 6 meter. Okay, so we can write 1 by 6 equals Y1 by 3. So Y1 equals 3 by 6, that is half, and you see this distance is 5 meter. This is 5 meter, so we can write 1 by 6 equals Y2 divided by 5. So Y2 equals 5 by 6. So reaction RA equals W1 Y1 plus W2 Y2. So 20 multiplied by half plus 30 multiplied by 5 by 6. So this is 10 plus 25, that is 35 kilonewton. So reaction RA will be 35 kilonewton. Okay, now calculate the reaction RB. So this is influence line diagram. The value is 1. This is ILD for RB. So you have to calculate this vertical line and this vertical line. So this is below 20 kilometer and this is below 30 kilometer. So suppose this is Y3 and Y4. Now this distance is 3 meter. So 1 by 6, 6 is total distance, 1 by 6 equals y3 by 3. So y3 equals 3 by 6, that is 1 by 2, and this distance is 1 meter. So we can write 1 by 6 equals y4 by 1. So y4 equals 1 by 6. Hence, reaction RB equals 20 multiplied by half plus 30 multiplied by 1 by 6. This is 10 plus 5. So 15 kilonewton will be the reaction. So this is 35 kilonewton and this is 15 kilonewton. Okay. So it is 35 plus 15, that is total 50 kilonewton, and we have load 30 kilonewton plus 20 kilonewton, that is 50 kilonewton. So summation of vertical equals to 0. It is satisfied. Now, so up to this we don't have any section. We don't need any section to calculate RA and RB. So now suppose this is 30 kilonewton load and this is 20 kilonewton load. This is 1 meter, 2 meter and 3 meter. So suppose this is the section, it is 1 meter distance from the left side. So this is suppose XX or x1 distance. Okay. So calculate the shear force at this x1 distance due to this application of load. So the influence line diagram for shear force. Now draw the vertical line below the section. So this will be the influence line diagram, actual influence line diagram for shear force. Now below 30 kilonewton, so this, and below 20 kilonewton we have two different height. Suppose this is y5 and this is y6. So this value is 1 and this value is 1. This is negative part, this is positive part. Now this distance is 1 meter. So 1 by 6 equals y6 by 1. So y6 equals 1 by 6 and this distance is 3 meter. So we can write 1 by 6 equals y5 by 3. So y5 equals 3 by 6, that is half. So shear force at x1 section equals 20 into half plus 30 into 1 by 6, that is 10 plus 5, that is 15 kilonewton, and it is negative shear force. Okay, so this is the negative zone, that's why it is the negative shear force. The shear force at this x1 distance due to this load is 15 kilonewton. Now just consider this section at different place and calculate the shear force. This is 30 kilonewton, this is 20 kilonewton, 1 meter, 2 meter, 3 meter. So suppose this is the section x2, x2. So first of all, draw the influence load diagram for ILD for shear force. So this is negative zone, this is positive zone, this value is 1, this value is 1. Okay. So this is the vertical line below the 20 kN load, and this is the vertical line below the 30 kN load. So this is suppose y7 and y8. Now from this triangle we have to calculate the y7. So this distance is 3 meter. So and total distance is 6 meters. So we can write 1 by 6 equals y7 by 3. So y7 equals 3 by 6, that is half. And from the lower triangle, this distance is 1 meter. So we can write 1 by 6 equals, this 1 is actually this one, okay, and this one is actually this one. So 1 by 6 equals y8 by 1. So y8 equals 1 by 6. Now shear force at x2 section, shear force at x2 section will be W1 y7, and this is positive, and minus W2 Y8. So because it is in a negative zone, so W1 means 20 multiplied by half minus W3 means 30 multiplied by 1 6. So this is 10 minus 5, that is 5 kilonewton. So the answer will be 5 kilonewton. At section X2, the shear force value will be 5 kilonewton. So now if you consider this section, you can easily calculate that the amount of shear force will be 35 kilonewton, that is the value of reaction at this point. Okay, so when I consider the section of this, the amount of shear force will be at this point, that is 15. Okay, so at this point you see this is 5, at this point it will be 35 kilonewton. So now let us take a different problem. Simply supported beam with overhanging. Simply supported beam with overhanging at one side. So suppose this is 30 kilonewton load and this distance is 2 meter. So this is 4 meter and this is 2.5 meter. So first of all you calculate the RA and RB, and then we shall calculate the shear force also for different section. So to calculate the reaction RA, what we have to do, first of all you draw the beam length, and at this point this will be the vertical distance equals to 1 unit, and here at this point the value will be 0. Okay, so yes, for the simply supported portion we have drawn the impedance line diagram. Now what about the overhanging portion? For the overhanging portion we have to consider the extension of this line. Okay, so this is the extension of this line and this will be the impedance line diagram for reaction for this overhanging beam, and this is the positive side and this is the negative side. The positive zone and negative zone. Now you draw this vertical line x1. So this distance is 6 meter and this is 4 meter. So you can easily calculate the reaction. So 1 by 6 equals to x1 by 4. So x1 equals to 4 by 6, that is 2 by 3. So reaction RA will be 30 into 2 by 3. So 20 kilonewton will be the reaction RA. Okay. And whatever the reaction RB, you again draw this beam length, and for the simply supported portion you just draw the impedance line diagram. So this is the portion of simply supported beam, and this value is obviously 1. Now for the overhanging beam, you have to extend this line. Okay, you have to extend this line up to this. So now, so this x2 distance you have to calculate. So we can write 1 by 6 equals x2 by 2. So x2 equals 2 by 6, that is 1 half. So reaction RB equals 30 into 1 by 3, that is 10 kilonewton. So 10 kilonewton will be the reaction RB, and 20 kilonewton will be the reaction RA. So this is influence line diagram for RB, and this is influence line diagram for RA. Let us consider one example. So this is simply supported beam with overhanging at one side, and so at this point 20 kilonewton load, and at this point so 15 kilonewton load. So this is 1 meter. So this is 3 meter, so this is 2 meter, and this is 1.5 meter. Now calculate the reaction RA. So at this point the value will be 0. And this will be extended up to the length of the beam for this overhanging portion. Now this vertical line you have to calculate. Suppose this is y1, and this vertical line you have to calculate. Suppose this is y2. This is positive and this is negative. So this value is 1. Now this distance is 3 meter. Okay. So the span distance is total 4 meters. So 1 by 4 equals y1 by 3. So y1 equals 3 by 4. and you have to calculate the y2. So you know this angle, those two angles are same. Okay, that's why you can consider and so this distance is 2 meter, so you can write 1 by 4 equals y2 by 2. So y2 was 2 by 4, that is, so reaction RA equals 20 multiplied by 3 by 4, and it is positive, and 15 multiplied by 1 by 2, it is negative. So the answer will be 15 minus 7.5, that is 7.5 kilonewton. And what about the reaction RB? So this is the influence line diagram for the simply supported beam, simply supported portion, and this extension will indicate the ILD for the other hanging portion. Now this height you have to calculate. Suppose this is y3 and this height, so this is suppose y4, and this value is 1. Total span length is 4 meter, so 1 by 4 equals y3 by 1. Hence y3 equals 1 by 4, and 1 by 4 equals y4 by this distance. Total distance will be 6 meter. This total distance is 6 meter. Okay, so this is 6. Hence y4 equals 6 by 4, that is 3 by 2. So reaction RB equals 20 multiplied by 1 by 4 plus 15 multiplied by 3 by 2, that is 27.5 kilonewton. So the reaction will be 27.5 kilonewton RB and 7.5 kilonewton RA.